All right, so before we talk about polynomial, and as you probably know, poly means many, so many monomials or many terms. So monomial means just one term. So the more specific definition, if I can get this thing to wake up here, there we go, is a number, variable, or product of a number and variables with whole number exponents. And we'll look at examples of all of these, but just real quick examples. So a monomial, a number, so it could be like 2, that would be a monomial or one term. So this means one term. A variable like x, or the product of a number and variables, so you could do 2x, or variables, you could do more than one variable like 2xy. Those would all be monomials, one term. And also the exponents would have to be whole numbers. Whole numbers mean 1, 2, 3, etc. So it can't be negative, can't be a decimal. So we could do 2xy squared, where the y is squared. The degree of a monomial is the sum of the exponents of the variables. And the key word here is the sum. So you would add up all of the exponents in that term. So the sum of the exponents of the variables. Okay, so for example here, if you just had x, the degree would be 1, because it's just being raised to the first power. Here you have 2x, the x is being raised to the first power, the y is being raised to the second power, so you'd add up the exponents. 1 plus 2 is 3. So here the degree of this monomial would be 3. So the degree is just a way to classify a monomial based on how many exponents it has. Because when we order a monomial or a polynomial, we want to order it from highest degree to lowest degree. So it's important to know what the degree of each term is. Okay, so let's look at some examples. So these are all monomials, all single terms. So let's classify their degree. Well, if it doesn't have a variable in it, then the degree would be 0. Here, x is being raised to the first power, so it's 1. Here we've got a to the first and b to the second, so 1 plus 2 would be 3. And then here you've got m to the fifth, and so that would be the degree of 5. Now the coefficient is negative in a decimal, that's fine, it's just the exponent can't be negative or a decimal. All right, so these are not monomials, and let's explain why. So this isn't because it's 2 variables. Sorry, not 2 variables, 2 terms. So it's not the product of these two, it's the sum. So that would mean that it's 2 terms. So if it's separated by addition or subtraction, then you separate the terms. Okay, 2 divided by n. Well, remember, this means 2n to the negative first. So this would be not a whole number exponent. So exponent is not a whole number. So the variable can't be in the denominator. For here, 4 to the a, well, the exponent isn't a whole number, it's a variable. So exponent can't be a variable. Exponent can't be variable. X to the negative first, and this would be the same thing as this reason that the exponent isn't a whole number. All right, so polynomial is the sum of monomials, so many terms. We'll say more than one terms or monomials separated by addition or subtraction. And the degree of the monomial is the degree the greatest degree of the terms. So the term with the greatest degree. And the leading coefficient is the coefficient of the term with the greatest degree. Coefficient of the term with the greatest degree. And so when you write a polynomial in standard form, you want to write it from highest power to lowest power, or highest degree to lowest degree. So if we have 15x minus x to the third plus 3, write it in standard form and then identify the degree and leading coefficient. So the negative x to the third has the highest exponent, so that would come first. And then we would have the 15x, and then we would have the plus 3. So 3 is just a constant because it doesn't have a variable. So anytime you have a constant, it's always going to go at the end because the degree of a constant is 0. Okay, let's do b. Oh, sorry. The degree. So the degree of this polynomial would be the degree of the leading coefficient, which would be 3. And then the leading coefficient itself is going to be -1. All right, so let's do this one. This is a really similar problem. So we've got -2y squared is going to be first, and then we'll have the plus 5y, and then plus 9. So the degree is going to be 2 because it's y to the second. The leading coefficient would be -2. Okay, for part C, you've got 3, 4, and 2, so the 4 is going to come first, -4b to the fourth, plus 3b to the third, and then plus b to the second. So the degree will be 4, and the leading coefficient would be -4 because that's the coefficient in front. Pretty easy so far. All right, a binomial, which we'll be looking at a lot in this unit. So binomials are polynomials with 2 terms. The trinomial has 3 terms. Okay, and then for class, we're going to classify it by degree as well. So here's the classification for degree. So when you're looking at degree, if it has a degree of 1, then it's going to be a linear function. If it has a degree of 2, then it's going to be a quadratic function. If it has a degree of 3, it will be a cubic. If it has a degree of 4, it'll be quartic. And anything else, you just say nth degree. All right, so 9, is it a polynomial? Technically, yes. It's a monomial. A monomial is, it's debatable. It depends on who you ask, I think. Monomial, I won't ask you a question like this in homework, just because you could think of it as yes or no. Is a monomial also a polynomial? That is kind of debatable, but the more important thing is that the degree is 0. And it is a monomial. So yes, no, it's a monomial, 0 degree. All right, here, this is a polynomial. It's all the criteria. Classifying it by its degree, well, its degree is 2. So that means it's going to be quadratic. And then the number of terms it has 3 terms, so that means it's going to be a trinomial. Okay, so you've got monomial, binomial, trinomial, and then anything else 4 terms and beyond you just call polynomial. Right here, this would not be a polynomial because you have n in a variable in the exponent. This next one will also be no because you have a negative exponent. This one is yes. So you've got let's look at the degree. So this term has a degree of 4 because you've got 1 and 3, but this term has a degree of 5 because you have 4 and 1. So that means that the degree is going to be based off of the term with the highest degree, which would be 5. So you would just say 5th degree, since it stops at 4 for specifics. 5th degree, and then since it has 2 terms, looking back up at this chart, it would be, oops, kind of messed that up here. It would be a binomial, since it has 2 terms. So binomial. All right, so now let's do some adding and subtracting of polynomials. So the adding and subtracting is not that hard. All you need to do is to combine your like terms. So here, if we're adding, then we're going to add the coefficients. So, and you only can combine terms with the same exponent or the same variables. So for the 2x to the third, sometimes I like to just write the whole problem down and then box or circle or star the ones that are like terms so I can combine them. So 2x to the third plus x to the third would be 3x to the third. So what we're doing when we add them is we're adding the coefficients and we keep the variables the same. So add or subtract coefficients and keep variable the same. All right, so then let's do the next power, which would be, so notice I took the highest power. Next we're going to do the second highest power, which would be 2. So negative 5x squared and 2x squared would be negative 3x squared. So minus 3x squared. So I've got those out of the way. Now the next degree would be 1, which would be the x, and it doesn't have any like terms. Negative 1 isn't a like term, so we would just have plus x and then minus 1 at the end. Okay, so that would be our addition. Okay, let's take a look at this one. The highest power is squared, so we'll do 3x squared plus x squared, which would be 4x squared. And I'm going to cross them out. And then we'll have x and 4x, which would be 5x. And then you've also got negative 6 and 10, which would be plus 4. And also notice that my final answer is from highest power to lowest power. That's how you want to write all of these answers. You don't want to have the highest power at the end or in the middle. All right, so let's do these ones. Now for this one, the original problem is not in standard form, so you have to be kind of careful. So we're still going to take the highest power first. So if you just look over your problem first, okay, so which one is the highest power? X to the third. So you've got negative x, oh, I don't want to cross over any other terms. Negative x to the third and positive x to the third, those are going to cancel, right? Because negative 1 plus 1 is 0, 0x to the third is 0. And then you've got negative 2x squared and 3x squared for the next highest power. Negative 2 plus 3 is 1, so that would just be 1x squared. And then you have plus 3x alone, and then minus 12 alone. That's your final answer for that one. Okay, let's try the next one. All right, looking over my problem, the highest power is 3, so I'm going to combine the x to the thirds first. So that'd be 5x to the third. And then I'm going to combine the squares, x squares next. So 2 minus 3 is negative 1, so minus 1x squared. You could also just do minus x squared. And then careful, don't do minus 4 plus x, do x and then minus 4 because the constant always goes at the end. So plus x minus 4. All right, so now we're going to hop over to subtraction. For subtracting polynomials, it's a little bit tricky when it's written like this. What we want to do first is get rid of parentheses by distributing this negative sign into the parentheses. So basically, you're going to take the second set of parentheses and flip all of the signs when you're subtracting. So we're going to keep the 4n squared plus 5, and then this is going to become plus 2n squared minus 2n plus 4. Okay, so now we can just combine like terms based off of what the new sign is in front of each term. So I'm going to take the 4n squared, that's my highest power, and the 2n squared, and that's going to become 6n squared. My next highest power is just n, so that's just minus 2n, it's alone. And then we've got 5 plus 4, which is 9. All right. Next one. So same thing, I'm going to distribute the negative sign into this parentheses. We can get rid of this parentheses because there's nothing in front of it. And then we've got minus 3x squared. I'm going to flip the signs, plus x plus 8. So now let's combine like terms. So the highest exponent is x squared again. 4x squared minus 3x squared. Make sure you include the sign in front of the 3. And then that would be 1x squared. And then you've got negative 3x plus x, which is negative 2x. And then you've got 5 plus 8, which is 13. So that's the answer for that one. All right. For C, once again, we'll distribute the exponent, or the negative sign, sorry. So 2c squared minus 8 minus 3c squared plus 4c minus 1. So we have 2c squared minus 3c squared is negative 1c squared. And then you've got the 4c that comes next. And then you've got negative 8 minus 1, which is negative 9. That would be that answer. All right, and for just the sake of time, I'm going to go ahead and let you try part D. Let's see, there is also an exit ticket that will be posted in Polaris, but I'm going to have you try part D by yourself right now. All right, so if you didn't get it right, here's how you would do it. So go ahead and distribute the negative sign. So 5y squared plus 2y minus 4 plus y squared, and flip the signs, minus 4y plus 3. The y squareds combine to be 6y squared. The 2y's combine to be 2y minus 4y is negative 2y, and then negative 4 plus 3 is minus 1. Okay, so after that, you have an exit ticket in Polaris that you're going to take, and that's all you have to do today. So just watch this video and go into Polaris and do the exit ticket, and tomorrow we'll do it in Edge Elastic assignment related to this lesson. All right, hope you guys have a great day.